Dear students, good morning everybody. I think you are watching all my previous videos based on the chapter motion, and already you know very well about the uniform acceleration, velocity, distance, displacement, time and all those things. Today we are going to learn about the equations of the motion which relate the uniformly accelerated motion in a particular direction, the various quantities involved in it and the relation among all those things. Let us first see the definition or meaning of equations of the motion. Let us say here the equations of the motion. Definition I am giving like this, rather meaning we can say equations of the motion are, now let us see this definition that equations of the motion are the equations which relate initial velocity, final velocity, acceleration, time and displacement when body is moving with uniform acceleration in a particular direction. In previous classes, I told you that the best example of the uniform accelerated motion in a particular direction is freely falling body. Today we will take up that freely falling body and the quantities involved in it and the relation between these quantities which will give the equations of the motion. The main use of this equation of the motion is that we can calculate, if some quantities are given, we can calculate the unknown quantities which we are going to see in the numerical problem. Today in this introduction we are going to see only the equation of the motion, how they are related, what are they and what are the quantities involved in it. First let me draw a simple diagram and then I will explain for a freely falling body in which uniform acceleration in a particular direction takes place. Now let us consider a body which is falling freely from this position, and here this is the initial position starting from 0 second, time is 0 second. It will start with a velocity 0 meter per second. Then let us say that after 1 second it has come here, fallen down. Then whenever it is freely falling, you know very well its velocity increases. Here it will become, let us say, 1 meter per second. Observe carefully, velocity 10 meter per second. Observe carefully, the velocity increased by 10 meter per second. After 2 seconds, let us say its velocity is increased to 20 meter per second. After 3 seconds, let us say that its velocity increased by 30 meter per second. I mean to say increased by 10 meter per second. I mean to say it has become 30 meter per second. And then after 4 seconds, it has become 40 meter per second. After 5 seconds, it has become, let us say, 50 meter per second. Okay, like that the velocity is increasing. Let us see here the velocity how it is increasing. Once again I will explain. Time is 0 seconds, 0 meter per second. After 1 second it has become 10 meter per second. After 2 seconds it has become 20 meter per second. After 3 seconds 30 meter per second, 4 seconds 40 meter per second, 5 seconds 50 meter per second. Observe carefully, in each and every second, after 1 second 10 increase. Next after 1 second 10 plus 10 20. After 2 seconds 20 plus 10 30. Like that every time it is increasing by 10 meter per second. Velocity is increasing. Velocity is increasing means it is having the acceleration. Okay. Now the direction of the acceleration is like this, downward direction. Acceleration direction is like this. Acceleration is indicated by A. And velocity direction is also like this only. You have to remember. Velocity also is like that only. And from here to here, that is called displacement. Displacement means from here to here, we call it as a displacement S we say. from here to here, or the simply we can say height also we can say, and it has taken, let us say, time t. How much time it has taken? Time t to fall from here to here, from point A to topmost point to bottommost point. This is the thing which is happening here. Now we are going to see the equations of the motion. First I will write that equations of the motion, then after you see how they are related, all these quantities are related. And one more point, here it is initial velocity, here it is final velocity. Let us see that. Here now I am writing the equations of the motion one after the other. In our syllabus we are having only 3 equations of the motion. In 11th class you will learn more about that equations. Let us see here. Number 1, V is equal to U plus AT. V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third equation is V square is equal to U square plus 2AS. These are the 3 equations. Okay. Once again I will repeat. First equation is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third equation is V square is equal to U square plus 2AS. Now dear children, please observe carefully what are the various quantities, or totally how many quantities are involved here. V, U, A, T, 4 equations here, 4 quantities, one more displacement, other things are repeated here. I mean to say 5 quantities are involved in all these 3 equations. 5 quantities are involved in these 3 equations. Let us say what are those 5 quantities. Those 5 quantities which are involved in this uniform acceleration in one direction is: number 1, initial velocity; number 2, final velocity; acceleration; time; displacement. Let us see here those quantities. I will write it. Number 1, U. What is U? I will tell you here. U is initial velocity. U is initial velocity. Number 2, V is final velocity. Final velocity. 3, A is acceleration. 4, T is time. 5, S is displacement. These are the various quantities involved in it. Okay. Now these quantities, let us see what are their units. And you know very well, all velocities are measured by the SI unit, meter per second. Therefore, here initial velocity, it is also measured by meter per second. Final velocity, it is also measured by meter per second. It's a very interesting thing. All of you remember that acceleration unit in my previous videos. You have learnt it. That is meter per second square. Time is second only. Displacement, it is in meters. These are all the 5 quantities here. They are involved in these equations. Now I would like to tell you the most interesting fact in these 3 equations. Let us see. Out of the 5 quantities, how many quantities are there in the first equation? 1, 2, 3, 4. Here let us say how many are there? 1, 2, 3, 4. T is repeated, don't count. I mean to say in this 4 quantities are related. In this 4 quantities are there. In this let us say 1, 2, 3, 4. Means in each equation 4 quantities are there. 1 quantity is missing. Let us say in the first equation S is missing. In the second equation V is missing. Third equation T is missing. I mean to say out of the 5, 1 quantity is missing. I mean to say 4 quantities are involved in each equation. One more interesting fact is that you will find that there are 2 quantities which are common in all the 3 equations. Let us say what are those things. I think you might have observed by this time, that is u here, u here, u here. I mean to say initial velocity is common in all the 3 equations. Next, a is there here, a is there here, a is there here in all the 3 equations. I mean to say that initial velocity and acceleration are common in all the 3 equations. Then the uncommon equations which are not common, let us see, v and t are not common in this equation. Therefore, this equation is called relation between the velocity and time. So, we call it as a velocity time relation. We call this as a velocity time relation. I think you understood why we are calling it as a velocity time relation, because this common one we have to remove it and the uncommon one we have to take that relation. You may ask, sir, why these u and a only are common here? Because these equations are for a body which is starting with initial velocity and moving with acceleration, okay. Now, in this equation s is equal to ut plus half at square, u is common, a is common, remaining things are s and t. Therefore, we can call this as a displacement time relation. We call it as a displacement and time relation. Finally, in this common one u and a are there, remaining 2 things are v and s. Therefore, we call it as a, v stands for, even though it is a final velocity, we call it as a velocity dash, what is this? This is a displacement relation. Third one, I repeat it. First equation is called velocity time relation. Second equation is called displacement time relation. Third equation is called velocity displacement relation. In the examination, it is a most important 3 marks and 5 marks question, derivations. In the next video, we are going to see the derivations. They will ask you derive the relation between the velocity and the time. Otherwise, they will give the direct equation also. If they give direct equation, no problem. But if they give the velocity time relation, you have to identify and derive it. In the next video, we are going to see the derivation of all these 3 equations. Okay. Now, quickly go through and try to understand the how many quantities are involved. In each equation, how many quantities are there, which quantities, physical quantities are common in this, and how the names are given to these 3 equations. Just try to understand. Now, let us see what happens to these 3 equations if initial velocity is 0. I mean to say that if the body starts from rest, if body starts from rest, you know very well, in the previous classes I told you that if body starts from rest, u is equal to 0 meter per second, but you have to remember all other things will be there as it is. Just let us see the equations and you substitute u is equal to 0 in the above equations, and then what happens, let us see. Now, you are able to see the equations here. In this above equations, we have to substitute u is equal to 0. Then what happens to the first equation? First equation, it will become Actually v is equal to u plus at. In this u has become 0, means u is to be removed. Then what happens here? V will be equal to simply at. Just you see, make it as a 0, then v is equal to 0 plus at, it will become at. From this we can say that, transpose the equation and we will say that t is equal to v by a. If you bring a this side, it will go to denominator, it is v by a. I mean to say, using this equation we can calculate the time. Time is a velocity by acceleration, provided initial velocity is 0. We are doing all these equations for initial velocity 0. Now second equation, let us substitute u is equal to 0 in this second equation. Here in the second equation, s is equal to 0 into t, then it will become 0 into t, 0 plus half at square. 0 plus half at square is equal to simply half at square. I am writing that s is equal to half at square. I think you have understood it. Direct addition of the equations here. That implies at square is equal to, cross multiplication I am doing, at square is equal to 2 into s is 2s. Okay. Now that from this we can say that, I am continuing here, t square is equal to two s by a, and therefore I am writing here t is equal to square root of 2s by a, means we can calculate the time from this equation. I am once again explaining, from the second equation we are getting this, s is equal to 0 plus half at square, we are getting half at square, cross multiplication, that at square is equal to 2s. Now I would like to calculate the t square is equal to 2s by a, and from that if you take the square root on both sides, t is equal to square root of 2s by a. So we have got here t value. Now let us see the third equation. Third equation, v square is equal to u square plus 2as. In this u is 0, we are saying, that is 0 square, it is 0 square plus 2as, we will get it, v square is equal to simply 2as. Now v square is equal to 2as we are getting, means we can say that v is equal to square root of 2as, or otherwise one more thing we can say from this only, 2a is equal to v square, and therefore we can say that s is equal to v square by 2a, like this also we can say. So these are all the equations of the motion, and special case when that initial velocity is 0. This is the introduction of the equations of motion. Just these equations of motion are very important. After watching the video, you by heart these equations with their description. All the three equations you must know that how many quantities are involved, how they are related, how they are useful. After completion of the chapter, we can do the numerical problems based on this. I think today you have understood the topic very well, I think so. All of you please go through the video once again, watch the video once again if you do not understand properly in the beginning, and I am going to send the homework questions after completion of the chapter, and we will do the numerical problems based on this after completion of the chapter. Thank you very much for watching this video. Now, if you like this video, give the comment in the comment section of the YouTube, whether you have understood it or not. You please give your name also. All of you give the comment in the comment box, so that I can understand that you have seen the video, you watched the video. Thank you very much.